given this chart, part A wants to know, is there a Condorcet Loser and is there a Condorcet Winner? Well, there is, and we found it by using the Simpson method, by showing that W wins every comparison and X loses every comparison. This means that W will be our Condorcet Winner and X will be our Condorcet Loser. Just rewriting this, we have W equals Condorcet Winner and X equals Condorcet Loser. There's many ways to find the Condorcet Winner and Loser. We just happened to find it using the exact same table in a previous example. So part B wants to know, what's the ordering under a Borda Count? A Borda Count, written B-O-R-D-A, assigns values to rankings, and the winner has the most value. It doesn't matter what values you assign, as long as you start with the highest and you get smaller as you go down. So we're going to do 4, 3, 2, 1. That means W has 4, 8, 12 votes, plus 2, plus this 1 vote. So this means W has 15 votes total under the Borda count. For counting X, there's none on the first row. We have 1X on the second row for 3 points, so 3 plus 2 plus 2, which is 4, plus 1 plus 1, which is 2, which equals 9 votes. For Y, we're given 3 plus 3, which is 6, plus 2 plus 2, which is 4, plus 1, which is 1. So for Y, we're given 11 votes. For Z, we have 4 plus 4, which is 8, plus 3 plus 3, which is 6, plus the 1, which is 1, which equals 15. Now we can see that W and Z have the exact same amount of votes under the Borda count. So just like we combined losers before, we're going to combine winners here. So we have W and Z is over Y, since Y has the next most votes, and then over X, since X has the lowest votes. Now again, you could do W equals Z over Y over X. These mean the same thing. I just personally prefer this comma. So this is our ranking under the Borda count. C wants to know, what is the ordering under plurality? Now plurality is really easy because you only look at the first choice. So given this table, we're only looking at the first row. So we have 1, 2, 3 W's, and we have 1, 2 Z's. So for W's, we had 3 as first choices. For X's, we had none. For Y's, we had none. And for Z's, we had 2. So this implies that W is the winner under plurality, followed by Z, followed by X and Y. Part D is plurality with runoff. Now plurality with runoff is very similar to normal plurality. We only look here at the first choices, but we eliminate everything except for the top 2 choices. Coincidentally, right here at the top choices, whenever we eliminate everything except for W and Z, all we're left with is exactly what we have in the first place, W and Z. An easier way to see this is, since we know W and Z are our first 2 candidates, we're going to eliminate X and Y. So when we go through the table and we eliminate every single X and Y, it doesn't affect the first place standings. It's still W with 3 votes and Z with 2. So our plurality with runoff outcome is going to be the exact same as part C, with W over Z over X and Y. The outcome would be a little bit different if instead of this W here, we had a Y, and then let's say instead of this X, there was a W right here. Then we have in first place a tie, with a tie between 2 W votes and 2 Z votes. So we would eliminate Y, and we would only look at the votes for the top 2 candidates, which is W and Z, and therefore we know that W would win. Part E is plurality with elimination. Now just like before, with plurality, we're only looking at the first choice candidates. Plurality with elimination means that whoever has the least amount of votes gets booted out, and the election is recounted. I already know the ordering is 3, 0, 0, 2 respectively for choices W, X, Y, and Z. Now plurality with elimination can keep going forever, so there has to be some kind of constraint. So you keep eliminating the bottom until somebody has over 50% of the vote. Well, how many voters are there? There's 1, 2, 3, 4, 5. This means that for one candidate to be the winner with plurality with elimination, they need at least 60% of the votes, so they need at least 3 out of 5. Well, looking at our first place row, we can see that W already meets this criteria, so W is already the winner under plurality with elimination. This type of ranking is not typical because usually there's not 2 candidates out of 4 that have 0 first place votes. So what would normally happen is, like we said before, usually there's somebody that has 1 vote in first place, and then that would mean we would eliminate X. If nothing changes there, then we would eliminate Y, and all of these votes would be either redistributed into W or it would be redistributed into Z, which would give us an above 50% vote. F is the ordering under the Copeland method. So given W, X, Y, and Z, we want to find W versus X, W versus Y, W versus Z, and then X versus W we already have, so X versus Y, X versus Z, and then Y versus W we already have, Y versus X we already have, so we need to find Y versus Z, and Z against all other candidates we already have in these choices, so we just need to find the outcome of these 6 elections. And we can cheat a little bit here. So we know that W is our Condorcet winner, and X is our Condorcet loser. So no matter what election we have between 2 candidates, if there's a W, W wins and gets +1. If there's an X, X loses and the other candidate gets +1. So we have +1 for W, we have +1 for W, we have +1 for W, we have +1 for Y, we have +1 for Z, and then Y versus Z we have to actually calculate, so let's go look at it. For Y in column A, it's a win. For Y in column B, it's a loss. For Y in column C, it's a loss. For Y in column D, it's a loss. And for Y in column E, it's a loss. So Z wins under this, and therefore it is a +1 for Z. And all we got to do is calculate the total number of votes. So for W, X, Y, and Z, we have 3, we have 0, we have 1, and we have 2. Which means our ranking will be W over Z over Y over X. And this checks out because we know W is our Condorcet winner, so it makes sense that it would win the most comparisons. Likewise, we know X is our Condorcet loser, so it should lose the most comparisons. G is Simpsons Rule, but if we go back up to the very first thing we did Simpsons Rule with this exact table here. So we know our outcome should be W and then Z and then X and Y, which again makes sense because we know W is our Condorcet winner, so it has to come first, and we know X is in last place. Even though it's tied, it's still in last place, and it's our Condorcet loser, so it should be in last place. And one other thing I didn't say is that if a voting method always elects the Condorcet winner, we say that that voting method is Condorcet consistent. This part is H, which is Baldwin's rule. This is my personal favorite because I love with elimination because you just get to boot out an entire candidate, and it also helps prevent ties in Borda Count. Baldwin's rule is a hybrid voting method. It is part Borda rule and part elimination. Going back to part B, we know that our rankings are W15, X9, Y11, and Z15. So let's write that out. W15, X9, Y11, and Z15. Now, like we said before, this is a tie and is really annoying because we don't have a first place candidate, we have 2. We get to eliminate the bottom candidate, which is X, and all of X's votes get redistributed into other choices. They may not go straight into W and Z, they just get distributed based on everybody's personal preference. So we go to this chart, we mark out everything that has an X since X was the lowest, and instead of it being a 4, 3, 2, 1 kind of ranking, this gets changed since we no longer have a last place in 4th. We now have 4, 3, and 2. And recalculating these, we have W with 12 for the first row, plus 2 for the third row, plus this W here was worth 1 point, but since it takes X's spot, it's now worth 2. So this gives +2 instead of its previous +1. So now this is +2, which gives us 16 votes. For Y, let's look at it. None of them are in first place. We do have 2 Y's here, so this Y should be in second place. This Y is in second place. This Y is in second place. So that's 9 for Y, plus this Y goes to third place, and this Y was already in third place, plus another 4, which equals 13 votes for Y. Z, we already have 4 plus 4, which is 8, plus these two choices didn't move, they're still in second place, so plus another 6. And this Z that was in last place now moves up and is worth 2 points, so plus 2, which is 16. Now, unfortunately, we still have another tie, so that means we boot out Y. And everywhere there's a Y on this table, we go and we mark it out. This also means our ranking changes from 4, 3, 2 to just 4 and 3. Once you get to this point of your Baldwin's rule table, it can obviously look very messy. But something to keep in mind, once you only have 2 choices, a choice is either worth 4 or it's worth 3. So if it's not in first place worth 4, it will have to be worth 3. And we know there's only 5 people voting. So for W, we have 3 first place that are each worth 4 points, plus 2, because 3 plus 2 is that 5, times 3. Now for Z, we have 2 that are in first place, plus 4, plus the remaining 3 that are going to be worth 3. These respectively equal 12 plus 6, which is 18, and that equals 8 plus 9, which is 17. And we can see that W is the winner because it has the most votes. And if we were to go on the next step to get our 50%, we would eliminate Z, and all these votes would be redistributed into W, and W would have over 50%. So we have W, next place would have been Z, next place would have been Y, next place would have been Z. To write this out, you just go backwards and you reverse the order in which you eliminated candidates. These were all the voting method parts of this question. If you have any questions, please feel free to reach out to me.